Another part of the clathrate energy materials is on silicon clathrates. As Craig mentioned, silicon also forms a clathrate hydrate, which has almost identical structures as the clathrate hydrates. And in fact, this structure is the structure 2 clathrate material, so equivalent to the structure 2 clathrate hydrate. But now you have silicon actually in the vertices of the cages. And so one of the ideas that we're investigating is to look at these materials for photovoltaic applications. There's been a number of theoretical studies by the group of George Nolas which suggests that these materials could have very interesting electronic properties, and by being able to tune these materials, because you can tune them by just using different guess materials, you can actually potentially tune the band gap of these materials. And so that's an effort that we're continuing on with Craig and Ruben. We were also interested in the original proposal at looking at the silicon and silica, because silica also forms a clathrate hydrate equivalent to, a clathrate material equivalent to the clathrate hydrate. And we were interested in looking at hydrogen storage in these materials as well. This is a temperature program desorption measurement from Anne Dillon's group, and where we were able to see some very small amount of hydrogen storage, but this is all physical storage we're talking about. So, so we're looking at the physical storage of hydrogen in these materials. And interestingly, this silica hydrate also occurs naturally. So this here is a Raman spectrum of the melanophlogite. So this is now, instead of silicon at the vertices, you have silica. And this actually occurs naturally, and the only site where it occurs has now been tarmacked in the US. But you can actually make them in the laboratory as well.